bonding unit. By the end of the presentation, you should be able to name CaCl2 and N2O5, write the formula for sodium fluoride and diphosphorus pentoxide, distinguish between ionic, covalent, and metallic bonds, and describe the difference between a polar molecule and a nonpolar molecule. So our first type of bonding is metallic bonding, and these are basically what we call alloys. And it's composed of two or more metals. So this would be like bronze, copper, and zinc, or tin, copper, and brass. And what you have is just a sea of electrons, where this positive charge here is the nucleus, and this red is just electrons, and they just freely move back and forth all over the place. And this is what makes them such good conductors of heat and electricity. We can just pass electrons right through there, no problem. So some characteristics include they're good conductors of heat and electricity, they're opaque, meaning you can't see through them, and they're relatively ductile, so we can shape them into wires. Compounds, ionic bonds. Ionic bonds transfer electrons. They're held together by electrostatic forces, and that just means the plus and minus charge, like a magnet, are attracted to each other. So cations are positive ions, and these are metals. They're going to lose or donate their electrons. Anions are negative ions, and these are the nonmetals, and they're going to take the electrons. They're going to gain or accept electrons. And a good way to remember that cations are positive. Y'all know I can't draw. My little kitty cat, and there's his butt, which is positive, so that's the cat butt. So cations are positive. Alright, your oxidation numbers. Basically, it's just the charge of an ion. And so if you're in group 1, you form a +1 ion. If you're in group 2, you form a +2 ion. So this means that this +1 charge means I lost 1 electron. Group 2 would lose 2 electrons. Group 3 lost 3 electrons. Group 4 can either gain 4 electrons or lose them depending on what it's bonded to. Group 5 is going to lose or gain 3 electrons. The halogens, oh, these aren't the halogens. The oxygen family will gain 2 electrons. The halogens, I don't know why hydrogen is over here, don't. The halogens will gain 1 electron, and of course the noble gases are already full, they don't want any. Now transition metals can have multiple oxidation numbers, so they have multiple charges. So in the name, I have to tell you the charge, or I have to tell you the ion. So to form an ion, it requires energy to pull off, or to transfer an ion. And this is what we call ionization energy. And the trend is, as you go up and to the left, up and to the right, it gets harder and harder to pull off that electron. And so the noble gases, of course, are going to have the highest ionization energy because they're full. They don't want to give away their electrons. But over here, group 1, they only have 1 to give away. So they're like, take it. Alright, so how do we write ionic formulas? What you do is you take the charge of this one, you take the charge of this one, and you just crisscross. So whatever's here, you're going to put here. Whatever's here, you're going to put here. So let's try magnesium and fluorine. So magnesium has a +2 charge, fluorine has a -1 charge. So I'm going to take this 2 and write it down here. And I'm going to take this 1 that we don't write and stick it over here. So I get Mg1, but I'm not going to write it, F2. Okay. Over here, potassium +1 charge, phosphorus -3 charge. Take your 3, stick it over here, and the 1 we don't write, stick it here. So you get K3P. So this subscript right here is telling me I have 3 Ks because compounds are neutral. I can't have a charge on a compound, so these have to balance each other out. Here, aluminum has a 3 charge, 3+. So I'm going to stick it here, oxygen 2-. I'm going to take the 2 and stick it over here. Al2O3. Alright, these are polyatomic ions, just meaning multiple atoms that have a charge. And you just have to be able to recognize these and memorize these. Alright, naming ionic compounds. So let's name this compound right here. We're going to write the name of the cation first, and my cation is the metal, so that's iron. And then you write the name of the anion, which is oxygen, but then add "ide" to the end, so oxide. Now, if the cation has multiple oxidation numbers, like iron does, because it's a transition metal, you have to tell me which iron it is. Well, I know from being able to crisscross that this 2 had to have come up here. And so, this is iron. This is not. We're missing something. Well, fart. That should be Fe3. Okay. Because iron 1 does not exist. Okay, let's get rid of this. Okay, so I have Fe. Nope, that doesn't exist either. Well, I shouldn't make things up in my head. Okay, new compound. Fe2O3. There we go. Okay, so I know this 2 had to have come from up here because oxygen has a -2 charge, and this 3 had to come from up here. So it's like going backwards from crisscross. So this is iron 3. So I'm going to write this in parentheses here. 1, 2, 3. And I use Roman numerals to indicate the charge. Alright, so do these, and then pause the video, do these, and then come back. So I have lithium has a plus charge, sulfur -2, so I crisscross and I get Li2S. Copper 2, so I'm telling you copper has a +2 charge. Chlorine minus charge, -1. Crisscross, I get CuCl2. Calcium and phosphorus. Calcium has a +2 charge. Phosphorus has a -3 charge. So I get Ca3B2. Zinc 1, plus charge, and acetate. Acetate is a polyatomic ion, one of those that you have to know, which is this. Just crisscross them like you usually do, and you get zinc. Always write your polyatomic ions in parentheses. Okay. Alright, covalent bonding. Covalent bonds are held together by sharing electrons between 2 nonmetals. So remember, metallic bonds were between 2 metals. Ionic bond, you have a metal and a nonmetal. And covalent bonds are 2 nonmetals. They usually have a low melting point. They don't conduct electricity. They're not going to break apart into water, into ions, like ionic bonds. And they could have multiple bonds. So you could have a single bond, which we represent with 1 line, a double bond, which we represent with 2 lines, and a triple bond we represent with 3 lines. And we'll get more into that in the next unit. So when they're sharing these electrons, you can have an unequal share or an equal share of electrons. With nonpolar covalent bonds, they're shared equally. So you get this nice shape here. And you get it from atoms that are identical, diatomic molecules, H2N2O2. These are the only 7 that do this, and you're going to have to memorize these. Polar covalent bonds, however, share them unequally. So you get this kind of weird shape where this atom over here is going to kind of hog the electrons. And when we write this symbol, this little symbol here, that's just saying, okay, this atom has more electrons because it has a negative charge. This one is more positive because it doesn't have as much of the electrons. And it's usually atoms of different size and different electronegativities. So like carbon dioxide or water. They're both C and O, they're both nonmetals, but they're different nonmetals. So electronegativity, this is just the attraction of electrons, how much an atom wants an electron. And you could get questions like this. They'll give you a little chart with these are the values of electronegativity, and electronegativity difference are often helpful in determining the bond character between two atoms. A general rule states that if the electronegativity difference between two atoms is between 0 and 0.4, a nonpolar bond would most likely form. Using the chart to the left, which pair of atoms would form a nonpolar bond? Okay, so you're just going to subtract. So you have H and S. So H is 2.1, S is 2.5. So that's 0.4. O and F, just subtract 4 minus 3.5, 0.5. H minus Cl, that's 0.9. Phosphorus minus oxygen is a lot greater. The point being, you just subtract, and it was this one. It would be mostly nonpolar. Okay, naming covalent compounds. You don't name covalent compounds like you name ionic bonds. When you name covalent compounds, you use prefixes to indicate the subscripts. So let's name this one. This is saying I have two N's. So dinitrogen, and these are the prefixes and subscripts over here. And you have 3 chlorine, so tri-chloride. You're still going to add the IDE like you do with ionic bonds. Now if I had CO, I have 1 carbon, 1 oxygen, I would not say monocarbon monoxide. This is carbon monoxide. You don't use mono with the first element. You just say its name. It's assumed you only have one of them. Alright, so practice these, pause it, and then we'll go back over it. Alright, so I've got 2 nitrogen, so this is dinitrogen. 1 oxygen, so monoxide, not monooxide, just use the 1 O. Here I have 1 nitrogen, so again, don't use mono, just nitrogen dioxide, because I have 2 oxygens. 2 chlorine, so dichlorine. I have 7 oxides, so heptoxide. CBr, so I have carbon tetrabromide. CO2, carbon dioxide. Okay, I have 1 barium. Now wait, barium's a metal. So this is an ionic bond. So I'm just going to call it barium chloride. And I'm not going to put the di in there because this is ionic. And you name ionics differently. No prefixes with ionic. Alright, so let's try and write these. Diphosphorus, so that means I have 2 phosphorus. Pentoxide, 5 oxygen. Tetraiodine, so I have 4 of them. Non-oxide, O9. Sulfur, hexafluoride, so F, and I have 6 of them. Nitrogen, trioxide. Carbon, tetrahydride. Phosphorus, trifluoride. Aluminum chloride. Aluminum is a metal. So I've got to write my charges. I got to know my charges. And then I have to crisscross because this is an ionic bond. So when you're writing these, you have to be able to look and say, okay, well this is 2 nonmetals, so this is a covalent bond, so I have to use prefixes. Here I've got a metal, And a nonmetal says ionic bond, so I need to use charges and crisscross. So you have to know what kind of compounds you're dealing with before you can just randomly start naming them. Alright, if you can't answer the questions at the beginning of the presentation, then you need to please watch it again.